All right, next I want to look at some tables. So this video has composition of functions when functions are represented by tables. I love tables as you're getting started with functions because it feels sort of puzzle-ish. I think they're kind of fun to walk through. And it really emphasizes some of the important details about how composition works. Okay, so we need to be really clear on what's happening in our table. We actually have two functions represented in the same table. The top row is x values, so these are the possible inputs for both functions, h and k. Since the second row is the h of x's, this is the outputs of h, and the third row, k of x's, are the outputs of k. Okay. So first thing is just to figure out how to evaluate this function. We're not going to work with formulas at all, so this is a little different than a formulas example, but just see how this actually works on a table. Okay, so if I want k of 1, 1 is my input. I need to go up here and spot the input 1 right here. And then I want to find the output for k. We've decided that those are in the bottom row, so the output of k is negative 1. So step number 1, plug 1 into k, get an output. Step number 2 is to plug negative 1 into h, and this is the part I really like about tables. It really forces you to actually physically do this movement where you say, okay, this was my output, but I want to use it as an input. So I'm going to move back up to the inputs row. So I'm thinking about this first as a y value of a function, but then I use it as an x value for another function. You'll have some graphs in your homework as well, and I think they kind of get at the same point. So if I'm inputting a negative 1 into h, outputs of h are in the second row. That means that I will get back a 0. And again, what's important here is that this tells us that h of k goes through the point 1, 0. So the input is 1, the output is 0. That negative 1 in the middle is just our work to figure out the final output. All right, we can switch it up. We could also do k of h of 1. So we're still starting with an input 1, so I start in the exact same column, but I'm plugging into h first. So I'm going to go to the h row, and I find my output is 3. So h of 1 is 3. I'm going to replace it with 3. And then this is telling me to take the 3 and plug it in. So I look for 3. Again, here's that swap. 3 was an output, but then I switch it and make it an input for the next function. I want k of 3, so I'm looking in the bottom row, and I'm getting negative 3. And again, the really key information here is that k of h goes through the point 1, negative 3. So the input for the composition was 1, the output for the composition was negative 3. All right, h of negative 2, so we get to start with a different input. There's our negative 2 in the inputs row. We want to first plug that into h. H is in the middle, so I get a negative 3. I am then supposed to take that negative 3 and plug it back into h. So here it was an output. I then switch it so that I'm thinking about it as an input, and I look for the new output of h, which is going to be a 5. So h of h goes through the point negative 2, 5. Inputs negative 2, outputs 5. Okay, last one, k of 2. 2 is my input, so I'm going to start with the 2 in the inputs row. I'm going to look for the output from k, which is an 8. I'm then supposed to take the 8 and plug it back into function k. Unfortunately, there is no 8 on my inputs row at all. And when you're looking at a table, unless I've said otherwise, I want you to assume this is the entire function. It's just a collection of 1, 2, 3, 4, 5, 6, 7 ordered pairs. Each one is a collection of 7 ordered pairs. So there is no input of 8, which means I don't have a possible output for h. The function is undefined. And specifically, the function I mean is this k of k. K of k is undefined if x is equal to 2. So this was an example of your composition, your domain problem happening on the second step. If I asked you for k of 7, that would be undefined as well. It would fail on the very first step. Here, k of 2, I made it through one step beautifully. I got out my 8, but I get stuck on the second step. So there's 2 different inputtings that you do, and either one of them can get you in trouble and force you to leave something out of your domain. Okay, let's see. Part B is asking us to do a solve. So let's see if I can find a different color here that works. I think this one's good. K of h of x equals 2. These I think are especially puzzly. And if you want to pause and think about this for a second, see if you can figure it out, I think that's a great thing for you to try. When I look at this, what I'm seeing is that 2 is the output that I get from k of h of x. So if it's the output of k of h, that means the final function that it came from was k. So I'm looking for how I get 2 to be an output of k. And here it is. Here's 2 as an output of k. And the answer is the only way to get 2 to be the output of k is if we input a 0. So I recognize that k of 0 is equal to 2, which means that h of x has to be 0. If I want h of x to be 0, again, that's an output, not an input. So I look for 0 on the outputs of h. There it is. And I figure out what I would have to input into h to get that 0. And the answer is -1. So this is what I'm proposing as an answer, and the easy way to check it would be to say, okay, supposedly if I plug this into k of h, I'm going to get back 2. So starting at -1, if you plug it into h first, you get 0. If you then plug 0 into k, you get 2, and that's exactly what we were hoping for. Okay, last part for this table, and I think this again is really good. Tables can be a really nice sort of simplified way of looking at what happens with composition and why we get weird domain problems. So domain and range of h of k of x. There is a really limited set of possibilities. So how do I want to say this? I would say that an x value is only a candidate if it's a valid input for k. So the possible inputs for k are -3, -2, -1, 0, 1, 2, 3. So it's definitely not even an option to try to plug something in if it's not one of those numbers, because you'll fail on the first step when you try and plug it into k. However, again, the really important thing to realize is just because it's okay to plug it into k doesn't mean that what you get back from k will be okay to plug into h. For equations, there's actually some really nice algebraic ways to just simplify them down and be able to see what inputs will get you in trouble. But for the table, it's really just kind of a trial and error process. So if we walk through this and we say, okay, so -3 is my input. I'm first plugging it into k. I'm getting 0. I then take 0 and plug it into h, and I get 3. So that worked beautifully. I input a -3, I got an output. So I'm going to say -3 is in the domain of the composition. I can also say now, let's see if I can remember where we ended up. I think I have to do it again. Okay, so we went -3, 0, 0, 3. I can also say that 3 is in the range of the composition. Okay, so far we've said yes to inputting -3 and yes to outputting +3. Now we can check -2. If I plug a -2 first into k, I get a 1. If I then plug the 1 into h, I get a 3 again. So this was valid. -2 did give me an input. I got a different 3, but it's still just the number 3, so I don't really have to write anything down in my range for that one. -1, if I plug -1 first into k, I get 6, And here's one where I'm going to get stuck. I'm not allowed to plug 6 into either of the functions. So -1 is not a good input, not because it gives me a problem with the inner function, but because what I get from the inner function does not a valid input for the outer function. 0 plugged into k gives me 2. 2 plugged into h gives me -1. So I'm going to add -1 to my range, and I'm going to say, okay, 0 was good for the composition. -1 is a good output for the composition. 1, if I plug it first into k, I get -1. If I then plug -1 into h, I get 0. So 1 is a good output, and I'm sorry, 1 is a good input, and 0 is a good output. Almost done. 2 first into k gives me 8, and then I get stuck. I'm not allowed to plug 8 into h, so I'm going to cross 2 off the list. Last one, 3 first into k. K gives me -3. If I then plug -3 into h, I get 5. So I get this nice ordered pair, input 3, output 5. So notice that all of the numbers are in the range, all of the numbers in the range of the composition are in the range of h, the outer function. All of the numbers in the domain of the composition are in the domain of the inner function. But depending on how your input-output pairs work out, you might not be able to use everything in the domain. So we were not able to use I think we were, and I just didn't check it off. We were not able to use -1 or +2, so this was an okay. And in the range, we never managed to get to the -3, and we never managed to get to the 9. So the domain and range for the composition will be some subset of the domain of the inner function and the range of the outer function. And as far as listing these, this is pretty much it. You could make it look a little prettier by putting some squiggly brackets on if you want, but you should just list individual values. You don't want to say something like everything from -1 to 5, because that would imply that you're including things like 1/2 and 3.2, and we really just want these 4 numbers. And then up top we get 5 numbers. So you don't need to list things twice. If you want to sort them and put them in increasing order, that's great, but not necessary. Okay. I've got a couple more table problems, and I want to do one, and then my advice would be to pause and try the other one. So the first one's the easier one, but just so that you understand how to read this, I'm going to walk you through. I have 2 different functions represented by tables again. So this is function f of x. These are the inputs and the outputs for f. And here we have the inputs and the outputs for g. And over here, we have function h of x that we're trying to find outputs for. And in the statement of the problem is the key piece of information. H of x is the same thing as g of f of x. So to find an output for h, we would take an input, we would plug it into f, we would take whatever we get and plug it into g. Again, I love the tables because they kind of force you to follow it through and really see the connection between inputs and outputs. So let's just walk through. If I want to find h of 0, the 0 is supposed to first go into function f. If I plug 0 into function f, I get out 4. I'm then supposed to take the 4 and plug it into g. So 4 is an output for f that I now want to use as an input for g. And g will then give me another 4. So a lot of 4s floating around in that one. Same process with 1. If I want to plug 1 into h of x, I'm supposed to first plug it into f. I get back a -2. I'm then supposed to plug the -2 into g, and I get back an 11. If I plug 2 into f, I get back a 2. If I then plug the 2 into g, I get back a 3. And then last one, if I plug 3 into f, I get a 0. If I plug the 0 into g, I get a -8. Okay, so this is as much information as I can possibly get for function h. So I'm going to walk through this next one as well. But again, I recommend, it's a little trickier, but I recommend that you pause and see if you can figure it out on your own, and then start up again when you're ready to check. So this one is a little trickier because I've left out not just outputs of H, but also one output of G and one output of F. So we have to kind of work between all three tables to figure them out. I can't just go X to F of X and then plug that into G of X. So I think I'm just going to start working my way down this list anyways. This tells me, again, H of X is G of F of X. So this tells me that if I plug a 4 into F, take whatever I get and plug it into G, I'll end up with a 5. So let's walk through and see if that tells me anything I didn't already know. Here's a 4 into F. I get back a 3. If I then plug the 3 into G, it does in fact tell me something I didn't know. I know because this tells me I'm supposed to get a 5, so I need to put a 5 right here. So the output of G has to be 5 because that's what gives me the values of the composition, the values of H. Okay, let's see what 5 negative 1 does. So 5 is supposed to plug into F. I get back a 7. 7 plugs into G. I get back a negative 1. Okay, so no blanks there, so that's all good, but it doesn't give me any new information. 6, I don't know what happens when I plug in 6, so let's go see if we can follow it through. When I plug in 6, I get negative 5. When negative 5 gets plugged into G, I get negative 2. Okay, 7, 6. So I know that if I plug a 7 into F, whatever I get out of F, I then plug into G and end up with a 6, which means I should be making it from here to here, right? I input a 7 into F. I should output a 6 from G. There's a blank spot here. So the question is, what has to be the output of F if I'm going to end up at this 6? And the answer is it has to be a 1. You have to have a 1 there if you're going to connect this. Last one, we don't know what happens when we plug in 8. So if I plug in 8 to F, I get negative 3. If I plug negative 3 into G, I actually get back an 8. Okay, so there was some looking at functions, composition with functions represented by tables. Thanks for watching.